Welcome and hello. This is a video exercise in HEC HMS, and in this exercise we are going to be dealing with reservoirs, specifically the outflow curve and rule-based operation methods. All right, what I have on the screen is an open instance of HMS. I'm going to start from the beginning here and go File, New to create a new project. Give your project a name, and then click on the folder icon to navigate to where you want to save your project. All right, I'm going to put mine right here, click Select, US Customary Units, and Create. All right, so I'm going to start from scratch here. I'll start with the basin model, New, call it Basin 1, that's fine. And then I'm going to expand to click and show the basin model on the screen here. Up in the Components toolbar, I'm going to add a source, which is right there. Then let me click the arrow tool and just move that right there. And here is my reservoir. I will add it right there on the map and create. I'm going to connect these two so that the source flows into the reservoir. I will just select that single left click and then a single right click for the context menu, connect downstream, and voila, click the reservoir. That connection has been made and save. Next, what I want to do is create that inflow that's going to be sent from source 1 into reservoir 1. This is going to be a time series data set. This is DSS view right here. If you're not familiar with DSS view, by all means, download it from the HEC website. All right, so we're going to get started here with File, New. This is my project location for HMS, so I'm going to go inside there, and then inside the data directory, that's where I'm going to save this DSS file. And I'll just call it something generic like data.dss. Okay, so that's been created right there. Next, what I'm going to do is create a time series data set, manual time series, and then I'll just say part C is flow. It's going to be a 1 hour time step, and this is going to be reservoir 1 flow for my part F. I'm going to say that this simulation will take place over the month of June 2024. So I'll just say it starts at the beginning of the month. The units for flow will be in CFS, period average. Okay, now I need to paste in some data here. All right, so I had some data prepared on my clipboard. I copied it from an Excel file, and then there it is. So let me just scroll down to the bottom of the month, and then I'm going to add one extra record. I found that's helpful, and then click Save. Okay, let's go ahead and take a look at that inflow data. So here it is. We have a base flow of 3,000 CFS, and then we have two noticeable peaks that go up to just above 18,000 CFS on about June 5th, and then again on June 13th approximately. All right, so I'm going to go ahead and close that, go back to HMS. If I click on source here in HMS, and then the flow method is going to be discharge gauge. I don't have any discharge gauges yet, but I need to create that discharge gauge for the inflow for source 1 and then link it to that DSS time series data set. So we'll go to Components, Time Series Data Manager, Discharge Gauges, New, and I'm going to call this Reservoir 1 Inflow, or I could call it just Source 1, but it's going to be the Reservoir Inflow. There's that right there. Now let's go ahead and select Reservoir 1 Inflow. It is going to be a DSS record. Now I need to navigate to that data file. Here's my project right here, and then data directory and data.dss. So I'll click select, then click on this button to select the path. It's my only path in the .dss file, so that's there. And then if I click save, the units and time interval update, so that looks good. All right, last step here is to click on the source, and then for the inflow, the discharge gauge, I'm going to select Reservoir 1 Inflow. Next, to run the model, I still need a control specification and a meteorologic model. So let's add those components. Control specification manager, new, control 1, that's fine. This is just going to be the same duration as that inflow data, the month of June 2024. Okay, that's been added. So let me expand and then actually define the start and end date time at 0 o'clock. That'll go till the 1st of July at 0 hours. And we'll use a 15-minute time interval. So we'll click save. Now the meteorologic model is not really needed as far as adding water because we already have this inflow. But before I can create a simulation, I need to have a meteorologic model. So let's do that. I'm just going to make it like a dummy met model. It's not going to have anything to it. So I'll click on that. I'm going to just say there's no precipitation. There's no nothing. All right. Next, what we need to do is define the reservoir. So I'll click on the reservoir itself. For the method, I'm going to start with something simple, which is the outflow curve method, which is just like a simple uncontrolled spillway. And then later in the exercise, we're going to be dealing with the rule-based operations: add a spillway, add a gate, and a rule in a zone. Okay, so for the method, I'm going to say outflow curve. Storage method is going to be elevation area, discharge. That looks good. Now I need to define these paired data sets, which define the geometry of the reservoir for elevation area, and then the flow function, which discharges as a function of the water surface elevation. These two paired data sets right here. So I'll go up to components and paired data manager. Now the first one will be elevation area, which is this one right here. Click new. I'm going to call this reservoir 1. Okay. And then the other one I'll just create while I'm here. This is going to be for elevation discharge, which is right here. New. I'm going to call this reservoir 1. And then I'm going to call this spillway. You'll see why later, but that's good to have that name. All right. Next, I'll open up that paired data set. For elevation area functions, I'll click on my reservoir 1. I'm going to use manual entry, and I've already prepared some data before this video and copied it onto my clipboard. And this is the data I'm going to use right here. Invert elevation, or a base elevation of 1350, a top of dam elevation of 1500 with these areas right here. So if I click on the graph, you can see what the geometry of that reservoir looks like. Next, I'm going to do the same thing for the elevation discharge. This is the spillway. I'm going to do a manual entry. I'll click table, paste in my data here. The invert occurs at 1420, so there's really no flow below a water surface elevation of 1420. There's very little volume there anyway, but then above 1420, that's when flow begins. All right, if we look at the graph, that's what this looks like right here. Of course, the broad crested spillway is the flow equals a function of the height of the water surface elevation over the dam, invert raised to the 3/2 power. All right, let's go back to the reservoir now and actually assign those data sets. Here's the area elevation. So reservoir 1, here is the spillway equation, and that looks good. I'll leave this initial conditions as inflow equals outflow. And then let's go ahead and create and run a simulation now. We should have everything we need. So I'll go to the compute menu, simulation run manager, new. I'll just call it run 1 and then use all the elements that I have. I'm only going to have one simulation anyway. So I'll select that, click the compute all elements, and then it ran in 1 second. So let's go ahead and take a look at that results. View results and graph. All right, very cool. So what we see here is two plots. The top plot has the storage and the elevation of the water in the reservoir over the course of this period. And then the bottom plot here is the flow. So what you see in the dashed blue line here is the inflow, and then in the solid blue line here is the outflow. I'm going to zoom in on this bottom plot with the flows a little bit closer, specifically the outflow. So if I zoom in on this one peak right here, we have a peak outflow from the reservoir, at least for this first peak in the inflow, of about 9,500 CFS, a little bit less than 9,500. So if I open up the table, I can look where it is. It's about 11 o'clock, 10 p.m. on June 5th. This column here is the inflow. This column here is the outflow. So let me just scroll down to June 5th. Yeah, it looks like we have a peak discharge of 9435.9 for that first peak. I'm only going to be focusing on the first peak, even though the second peak is just as valid. One thing that's interesting would also be to figure out what the stage would be downstream if there was a reach downstream of the reservoir. So I'm going to add that real quick. We'll add a rating curve, see what the elevation is, and then we're going to go ahead and add a gate and a zone to our reservoir and then run the simulation one more time. All right, so to do that, I'll click on the reach button here. So I'm going to add a reach. I'll call it reach 1. That looks good. And then after that, I will add a junction just to give the reach something to connect to. All right, so I'll click the arrow tool here, select the reservoir, right click, connect that to the reach. Now, if I select the reach, I should be able to right click, connect downstream to the junction. All right, let me just move that right up there. All right, so the reach properties, I'm going to go ahead and click on reach. We'll use a lag routing that has no attenuation, therefore the delay in peak will just be whatever I specify on this routing tab. And I'll just say it's, I don't know, 200 minutes. That's not too important. We don't care about the junction too much. We're interested in the reach. Also, this reach in the options tab, this is where I would define the stage discharge. Now, I don't want to use the reservoir spillway paired data set. I want to define a separate paired data set for the rating curve in this reach. So I'll go up to Components, Paired Data Manager, Elevation Discharge, New. Now for a name, I'm just going to call this Reach 1 Rating Curve. So I'll close that, go up to my paired data, elevation discharge. Here's that rating curve table, and I'm going to paste in some data. So here's the graph of it. The elevation ranges from 1350 up to 1362 with the discharge right here. So if the discharge is 10,000 CFS, that would get up to about 1360.5. If it's 6,000 CFS, the elevation of the water surface in that reach would get up to about 1359 and so on. So let me save that and then run the simulation one more time. That way I can view the results of the reach. We'll click on the results tab this time, run, click on the reach, and then I'm silly. I need to first assign the reach to that rating curve. So let me click the reach, click the options tab, and then select reach rating curve. Okay, save, run, and then let's go to the results now. We should have, there it is, a stage record right here. Okay, so we have a total stage for that first peak. The peak elevation is 1,360.35. Now, say for instance, the peak elevation that was allowed was 1,360. Well, we can modify our reservoir to release more water earlier, like before that storm, that inflow hydrograph even gets to the reservoir. So I'm going to go ahead and do that now. At this point, we could, in our components tab here, create a separate model, a separate basin by just making a copy, but I'm just going to use this one right here. So I'll click on the reservoir, and then the method, I'm going to change this to rule-based operations. Now we have a lot more options with this method. Before, I'm going to go with area elevation, and then I need to define that once again. Okay. The initial conditions are the same. For outlets, I'm going to say 1. For spillways, it'll be 1, and then zones will be 1. So this is still a very simple type of reservoir, even though I am using rule-based operations and I do have a zone. It's only going to be one zone, though. Let's go ahead and make some parameter value assignments. So I'll click on the reservoir. The plus symbol will allow me to expand it. Then if I click on zones here and then click on zone 1, what it's looking for is a maximum elevation, and this is a paired data set. I believe this is daily elevation pattern. So I don't have any defined right now, but that's what we're going to do next. Keep in mind that top elevation of the reservoir is 1500. So if I set an elevation above 1500, then and make it my only zone, then that's one way to keep all the reservoir operations for the entire simulation in that one zone. That's kind of the safe way to do it. So I could just be absurd and call it 1600 because the water surface will never get above 100 feet above the dam face. Okay, so I'm going to go up to Components, Their Data Manager, and then this is towards the bottom, I believe. There it is, daily elevation pattern, new. So I'm going to call this reservoir 1, zone 1. Actually, so how about zone 1 top? Okay, top elevation and create. All right, to the paired data manager, daily elevation patterns. Here it is. I'm just going to do a manual entry. So I'm going to just type in what I say, 1600 feet. And then I don't want to type that for every day of the year, and I don't have to. I can just hold down Shift and then hold down page down to highlight all the records. And then I'm going to right click, fill, and then repeat first value and OK. So that's been copied for every day of the year and saved. Okay, so now I should be able to go back to the zones, expand that, zone 1, and then maximum elevation is right here. The storage objective, this is going to be my guide curve. The storage pattern here is a paired data set. So let's go ahead and do that. I'm going to go up to Components, Paired Data Manager once again. Now this time I'm going to select, there should be a storage pattern somewhere. Oh, there it is, storage pattern, new. I'm going to call this Reservoir 1 Guide Curve. Now to keep things simple, I'm just going to keep a constant guide curve of storage for the entire simulation. So I need to define that, and let's do that. Storage pattern, there it is. Manual entry, once again, lots of manual entry in this exercise. I'm going to set it at 17,526. I want to set it at whatever elevation is equal to that constant 3,000 CFS base flow. So to do that, let me just double check my results, and I may have to come back and edit this number, but I think it is 17,526. Anyway, I'll go to results. I'll go to run reservoir. I need storage. Okay, so let me pop that out and look at the data. So if I zoom in here, yeah, it's going to be 17. Let me just get the number from the table. 17,526. Is that what I had? Let me go back to my reservoir here. I'm sorry, it was at the guide curve table, 17,526. Okay, just double checking that I got the right number. So if I click on the graph, it's a very boring, just constant storage for the entire year, even though our simulation is only for the month of June. Back to the reservoir here. I'll expand the reservoir. Here's the zones. Now for storage objective tab, I can select that reservoir 1 guide curve. And then we can now move on to the outlets. We're going to have one outlet. This is going to be a controlled outlet. And this is where we're going to release water from the reservoir before that large storm comes, before that inflow hydrograph attacks our reservoir. For the method, I'm going to select general outlet, direction, main, and then for minimum and maximum discharge, these are two more paired data sets that I need to define. The minimum is going to be trivial. It's just going to be 0. So let me go ahead and do that. And also the maximum at the same time. This is going to be an elevation discharge function. Now I'm going to call this reservoir 1, outlet 1. Let's see, outlet 1, and I'll call this min. Okay. And then create new. And then I'm going to call the other one max and create and close. Now let's go ahead and define that data. Here's the paired data manager, elevation discharge. Here's the minimum. It's going to be a manual entry using these same units, feet for elevation, CFS for discharge, and voila, there's my table. It's just a constant 0. For max, we'll click on paired data tab and then table, and then paste in the numbers here. And then if I want to look at the graph, you can see that the invert's at 1420, and then that maximum allowable release with 100% gate open increases as the headwater or the water surface elevation in the reservoir increases. So let's save that. Let's go ahead and go back to make that assignment. Here's the outlet. Let me click on outlet 1. And then for max discharge, or sorry, this is min. And then this right here is max. Okay, next up we have a method. Gotta love it. There's a method here. There's a method here. But what we want to select here is the percent annual pattern. Just kidding, percent time series right here. This refers to the percentage that this particular outlet gate is open with respect to time. That's why it's a time series data set. So I need to define another data set, this time a time series data set that is a percentage. So between 0 and 100%. If we look at the results from the previous simulation run, in fact, I'm actually going to just look at the source data. So this is our time series data set. What I'm going to do is open the gates before the flow occurs. So for instance, on this first inflow right here, what I'm going to do is open the gates for that outlet a day early. So maybe like for June 3rd and June 4th. And that will bring the storage and the elevation of the water in the reservoir pool down so that there's more storage and availability in the reservoir, and also it will decrease the peak flow and hence peak stage downstream of the reservoir. And I'm going to close this gate around probably the end of the 4th of June 4th, and then just let the spillway flow take over from there. I'm going to do a similar thing with the second peak right here, but I'm just kind of focusing on the first peak at this moment. All right, so let me close that. All right, so I'm going to go up to components, time series data manager. For the data type, I'm going to select percent gauges and then new. And then for the name, I'll call this reservoir 1, outlet 1, percent time series. Click and create. I can close that. Now in the components tab of the Watershed Explorer, we should have a time series data set, percent gauges, and let's click on that record there. Now this time I want to make it a DSS path. We're going to have 720 records. So I'll go back to DSS view and then data entry, manual time series. For part C, I'll call it percentage. And then for part F, reservoir 1, outlet 1. Okay. All right. So the start time here will be June 1st, 2024 at 0 hours. The units will be blank, or well, there'll be a percentage, I guess. Does that work? Okay. And then instantaneous, it'll really be period average. And then the data will go right here. Okay, I've copied the data over from my Excel file, and then I'll click paste right here. That looks good. And then let me add one more record just to be safe, and save. Okay, so that's been saved. And then, no, I don't need to go to the edit screen. Let me go ahead and just look at that plot, the plot, not the table. There we go. All right, so we have that gate opening for a couple days here for the first inflow of water, and then another day, 2.5 days or so later in the month, about a week later in the month, for that second inflow hydrograph. Let's go back to HMS and make that assignment. So here is the reservoir, then here is the outlet. Here is the time series that dictates when that outlet gate is open. I'm just opening it up 100%. I'm not opening it up halfway or anything like that. That's something we could do for fine tuning a little bit later. All right, and then for the spillway, this is something we've already done. For the method, I'm going to say specified spillway right here, which is what we already had defined. So I should have my reservoir one spillway defined already, which we do, and that's why I named it that, just so it's obviously the correct one to select. All right, so I'll click save, and I think I'm ready to rock and roll. Let's see what happens when I click compute. Okay, so we have an error. Specified initial condition for reservoir 1 is above the maximum table value. Let me check that out real quick. Reservoir 1. Okay, you know what I'm going to do for this initial condition? I'm just going to set it equal to the elevation that we saw from our previous results. So this elevation, pool elevation, let me just look at the data there. I could open up DSS view and get the same data that way, but let me just get the first record here. And we're looking at 1441. Okay, so I think that should fix the problem. I'll go to the components tab and then up to my reservoir. And then for initial condition elevation, I'll call this 1441 and save. Okay, let's see if that runs now. Okay, it looks like it's running. That's good. It's running much slower than it was in our earlier simulations, if you notice that, because it's got more to compute. All right, looks like we are done computing. It took 45 seconds that time and a little bit slower than 1 second. And let's go ahead and look at the results. Right click and view the graph of the reservoir. Ah, all right, I figured out what the problem was. There's a lot of moving parts and pieces going on here. But what I needed to still do is assign that DSS, the percent gate open time series dataset, to the percent gauges time series dataset right here. So I'm in the components editor. I'm clicking on that record, and then I want to go to single DSS record. Let me navigate to the DSS file I want, data.dss. Okay, I'm going to click on this button here. Now what I want to select is, yeah, I was off camera making one additional one, but this is the one I want, I think. All right, let's go ahead and save it and then run it. Watch that go. It looks like it might be going a little faster this time. Okay, that looks like it worked. Runtime was 23 seconds. Let's go ahead and take a look at the results. So right click on the reservoir, view, graph. Okay, very cool. Looks similar to the previous run so far. Actually, you know what I want to do? I'm going to click on the results tab. And then what I'm going to do is expand the, yeah, reservoir is what I want. And then click on the outlet right here. All right, that looks interesting. And then we have the spillway, that's flow out of the spillway. And then the total flow would be the sum, which is right there. I'm going to open this up in a separate plot here and then add some color. So I'll go to edit plot properties, just make it a little bit thicker. And then the next series, I'll give it a different color, maybe green, and then a solid line and a little thicker. For the final series, I'll give that a different color as well. How about red, solid line and thicker, and then apply and okay. All right, let me make this a little bit bigger for me. Interesting. So what we have is the outlet in blue, and that makes sense because we turn it on. We open the outlet 100% for 2 days here and then 2.5 days here. And that's why we're getting the flow. It's not a constant flow because remember the water surface elevation is changing. So HMS is doing the math and trying to figure out what exactly how much flow happens. And then the green plot right here, this is the flow over the spillway. So the sum of the blue and the green is the red. That's the total because those are the only two mechanisms for water to pass through the reservoir. So very cool. The objective here was to minimize the peak flow, the peak discharge, and hence the peak stage. Speaking of which, let's check out what that peak stage is. I probably should have ran a separate simulation so I compare the previous one, but oh well. Let's expand the reach and then look at the stage now and make it a large plot. This is the peak stage value here. So 1360.3. I think it came down a little bit, but this exercise has been going on long enough. I did want to say, though, that if you're interested in reservoirs, by all means, check out HEC Res Sim as well. On this channel, I have a number of videos, lessons, and exercises where we go into more detail about reservoirs, reservoir operations, and here in HMS, this is good for what reservoirs are used for, but it's not really the focus of the software, whereas HEC Res Sim, it really is. So anyway, that was it for this exercise. In HMS, we dealt with reservoirs, specifically the outflow curve method and rule-based operations method.